All right, so welcome to today's lesson. We're going to be continuing our discussion on law of cosines here. But before we get started on this wonderful 21st day of April, before we get started, I wanted to ask a quick question, a little pop quiz. Get excited, okay? At this point, it's a good question to start thinking about. You got a test coming up next week. All right, Monday, Tuesday of next week, we got a test. So a nice pop quiz to think about would be this. When would you use the law of sines versus using the law of cosines? Hopefully you know when you can versus when you can't use the law of sines, and when you can and when you can't use the law of cosines. Um, if you feel caught up and you feel good, you should be able to answer this question. If you want to kind of dig deeper into this question, I'm not actually going to answer it here. I've answered it in a previous video that is on my channel that literally says law of sines versus law of cosines is the title. And so you can go find that and watch that video, and that'll walk through it. But I just wanted to point it out. You need to know this. This is not a joke. Right. This is like, if this is what this whole unit is about, it is this. It is this question, like, what's the difference? When would you use one versus the other and why? And just kind of rolling with that, okay? Like that is going to be the thing that's kind of, you know, separating you from being able to pass this test and do well versus maybe things are a little shaky and you're not really caught up. But for day two of law of cosines, right, as we hang out in day two of law of cosines, we're just going to do some word problems. And I'm going to walk through them and talk through them. If you don't quite get why I do something, please send me an email or put a comment in the video. That'd be fine. And let me know, um, and I can help you out. Okay, but these word problems are kind of fun because I feel like you have to like really be in the word problem. All right, to really kind of like get it. So here we go. Right. So it says from port, a ship travels due west. I'm gonna underline some things that seem important. Due west for 87 miles. It then travels in a northern direction for 78 miles and ends up 155 miles from the port. So how many degrees did the ship turn when it changed direction? Okay. How many degrees did the ship turn when it changed direction? All right, so let's just start this. I'm going to put in a little help here. Never eat shredded wheat, which is bad advice. I think frosted mini wheats are pretty tasty. But anyway, right, never eat shredded wheat, never eat soggy waffles, never eat sour watermelon. I've heard before. I've seen that seems silly. But anyway, there it is. Okay. Um, so we're going to go due west, which means you just start at wherever you're beginning. So I'm going to say that this is a port, and you're just going to go due west. So the ship is sailing this way. So you're envisioning the ship sailing that way. Okay. Hopefully everybody like be on the ship. If you really want to get this down, be on the ship. Okay. Put your body, your mind, close your eyes. Well, don't close your eyes because then you can't watch the video. But right, be on the ship. So there you go. You're going straight to the west, going headed west. Then we're going to turn, it says in a northern direction. I'm just going to turn in the northern direction, okay? You say, how do you know it goes that much? I don't know. I'm just making stuff up here, okay? So it goes in a northern direction. Boom. Okay, that's 78 miles. And then it goes for 78 miles that way, and then apparently it just stops. Maybe it gets to where it needs to go, and it says that the distance away from the port is 155 miles. Okay. So the first thing we should do is we should say let x be the angle, right? The ship turns. So I'm going to ask a serious question. I want you to put it into the picture that we've drawn. I'm not going to draw it. You draw it. I'll pause for a second. You can hit pause. I don't care, but I'm going to wait and I'm just going to throw it out there. Where do you think X goes in the picture? Okay, so let X be the angle the ship turns. Where do you think X goes in the picture? I'm just going to let that hang there for a few seconds. Okay, if you, I literally want you to like draw an X on your notes. Where would it go in this picture? Okay, that's what you're thinking about. If you need more time to think, hit pause. Okay, and think about where would I put the angle? Like, where's the ship actually turning? Okay, all right. So if you want more time, hit pause. Otherwise, here I go. The ship is sailing due west. Okay, so you have to imagine an actual ship sailing. When that ship turns, it will have been facing that way, and then it turns up north. This is the angle that the ship turns. If you put the X on the inside, this is not the angle that the ship turns because the ship is not facing east. The ship is facing west. So when the ship faces west and it turns up, that is where the variable will go. Now here's the thing, is this is the angle, I'm going to just call it theta. You actually have to find that angle first because there's no other way of doing this problem without it. So let's get started. This is a law of cosines problem because you have all three sides. So 155 squared equals 87 squared plus 78 squared minus 2 times 87 times 78 cosine of theta. And if you have a TI Inspire, you can do menu 3-1 if you want. Make sure you're in degrees. I do not. I just have Desmos on my phone, so I'm going to do some quick math. 155 squared minus 87 squared minus 78 squared is going to all be divided by -2 times 87 times 78. And that is what cosine of theta equals. Then I'm going to do the inverse of all that trash. So 155 squared minus 87 squared minus 78 squared over -2 87 times 78. And that equals theta. Okay. Bear with me for a second. I'm going to put all that into my calculator, but that is how you do the problem, right? And so I want to just remind everyone, this is not going to be my answer. Yes, right? This is just going to help me find the answer, but it's not going to be my answer. Okay, divided by -2 times 78 times 87. Okay, I get 139.8 and it says round to the nearest degree. So we'll just say that theta is roughly 140 degrees. So this guy right here is 140. How does that help me find X? Well, two angles that make a straight line are called a linear pair and they add to 180, right? They're supplementary. So X is just going to be 40 degrees. Right, so if I want to write myself a sentence, kind of wrap this whole thing up, I could say the ship turned 40 degrees in a northern direction. Okay, so I love this problem because you could guess why, right? I love this problem because most of the time people tell me that theta is the right answer. So they say, oh, 140 degrees in the northern direction. That would be false. It's going to be 40 degrees in the northern direction because you got to remember the ship is facing to the west. Okay, all right, so there's our first question. Hopefully that made sense and you're feeling good about it. Okay, it says a pilot flies in a straight path. Okay, nice. Probably important, straight path for an hour and a half. All right, next. It then says she then makes a course correction heading 10 degrees to the right of her original course and flies 2 hours in the new direction. If she maintains a constant speed of 625 miles an hour, how far is she from her starting position? Okay, so this doesn't really matter where you put the starting position. I'm just going to put her starting position here. Okay. And she's starting to fly, and she's flying for an hour and a half straight. Looks pretty straight. Okay. And she goes for an hour and a half. And she's going at 625 miles an hour. So to figure out how far she went, 625 times 1.5 is going to be 937.5 miles. Hopefully that makes sense, right? Distance equals rate times time. So 1.5 hours times 625 miles an hour will tell you how far she went. So she went that far for her first part. But then it says from her original trajectory, right? So here's her original path. She then is going to go to the right of that. So if we were putting ourselves on the plane, to the right of that would be this side. And she's going to go 10 degrees to the right of it now. So course correction, she's a little off. And there's 10 degrees. So this right here is 10 degrees. Okay. So she then moves 10 degrees to the right. She continues on 2 hours at 625 miles an hour. So 2 times 625 is 1250. So she went 1,250 miles. This is how far is she from the starting position? So that's going to be this right here. So starting position all the way to where she is. Whew, okay. There we have it. We have a triangle. Right? How far is she? This is x. That's not too bad. Right? Let x be the distance away from the start. Okay, so that's going to be how far she is from the start. And we don't know all 3 sides, but we know 2 sides, and we know this 10 degrees, which means we should be able to figure out this obtuse angle, which they add to 180, so this should be 170 degrees. So we know this is law of cosines, because you have side and the side, and then you know the angle in between. So side, angle, side. That's why I'm going to use law of cosines. And so we'd say the opposite side squared, x squared, equals, right, 937.5 squared plus 1250 squared minus 2 times 937.5 times 1,250 cosine of 170 degrees. Okay, now all the work you need to show is just square root and square root, and we'll figure out what x equals by putting that in a calculator. Once again, bear with me. It's going to take a second. 937.5 squared plus 1250 squared minus 2 times that times cosine of 170. I'm in degrees, yes. So I've got 2,179.35 miles. Okay, 2,179.35 miles. So that's how far. All right. She is 2,179.35 miles from her starting position. Hopefully that makes sense. Not too bad. The key to both of these pictures is going to be really making sure that you read the problems carefully. So maybe employ some idea of underlining. Really look for words that will kind of lead you to the picture. I think that's really important as you kind of analyze this. You're not necessarily always like if you notice, I didn't necessarily highlight these numbers. Like, yeah, okay, that makes sense. The numbers are probably important, but that's like a very algebra 1 kind of way to read a word problem. in these word problems, you're really trying to draw the picture. So the picture is going to be everything to you. So sure, yeah, I know I need to know about the numbers, but more importantly, I need to know about the directions. I need to know that the ship is turning. Okay, so like these become more important because I'm trying to draw the picture. So hopefully that kind of helps as to what you're looking for, right? And kind of things. This is the key to this problem. She then makes a course correction, right? Heading 10 degrees to the right. And so that's going to be the thing that makes or breaks this problem for you. Okay. If you have questions about either of these, let me know. All right. I'd love to help out. There's a couple of good ones in the homework tonight. And I'm going to actually make a video about two of my favorite ones from the homework, and I'll share it later today with you guys. Okay. Um, all right, so we got this one that says find the measure of angle P for the parallelogram below to the 10th of a degree. So we're finding measure of angle P. Okay, so this is this guy right here. I want to find it. Well, let's talk. If it is a parallelogram, what's true about a parallelogram? Well, if it's a parallelogram, then opposite sides are the same. So this is actually 26 inches as well. That means this is 28 inches. Okay, so if we're talking to each other about law of sines and law of cosines, why are we talking parallelograms? Well, because when you draw the diagonal of a parallelogram, guess what? It makes two congruent triangles. And so we can wrestle with the idea of this triangle, right? So can we find angle P? Hopefully you are saying yes, yes, because it's side, side, side. And if it's side, 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 and I know all three sides, that means we're going to use law of cosine. So 37 squared equals 28 squared plus 26 squared minus 2 times 28 times 26 cosine of, and I'm going to use P because we're looking for angle P. All right, so if you've got this down, if you've done it enough, you kind of already know that you're going to end up doing the inverse cosine of 37 squared minus 28 squared minus 26 squared all over negative 2 times 28 times 26. And I'm comfortable with you moving from here to here in that step by just showing it, right? Showing you what's going in. And I'm totally okay with that. So inverse cosine 37 squared minus 28 squared minus 26 squared all over negative 2 times 28 times 26. And it says round to the nearest tenth, so I get 86.4 degrees for P. Boom, done. There you go. Okay, so hopefully that all makes sense for a lot of cosines. Like I said, the homework is not too bad. It's like 8 questions, okay? It's a problem set on Canvas, all right? So go check it out on Canvas. Should be pretty great. There's a couple of them that I think you will enjoy wrestling with. And you can check back for some help if you need it, or I'll send it out, and that could be a good way to do it too. All right, well, hopefully you have a great day, and I will talk to you later.